So today we're going to be talking about two proportion z intervals. So you can see in front of you, I have what we did before, the one proportion z interval. And everything we did in chapter 19, the confidence intervals there, were a one proportion z interval. So today, you'll see in pink, we are going to start the two proportion z interval. This is when we have a difference in proportions. So that means that you're going to have two separate samples and we're going to compare them. So I'm going to give you the formula. It's really long when you first see it, but once you do it a few times, it's not so bad. So in our formula, we're going to have a P1 hat and a P2 hat, and we're going to find their difference. Then we're going to do that, plus or minus our z star again. And for our square root, we're going to, instead of just doing one p hat and q hat over n, we're going to actually do two of them. And we're going to add them together. So you may remember that this term here that we took the square root of was our standard error. You sometimes see it written as SE of p hat, which is kind of a fancy way to write it. We often just write it as SE, but it is our standard error. And in our new equation, it's the same thing. The only difference is that we have a slightly different notation for it. We do the standard error of our difference between our p hats. So let's do an example. Our first example asks the question, who's more intelligent, men or women? So you probably won't be surprised to find that there is a difference in opinion between the two genders. So we can't just automatically say that because this is stats class. So we have to actually show a confidence interval. You can also do a hypothesis test, but we're going to do an interval here. So especially in cases where you have two proportions, it's always a good idea to write down all of the information that you have in the very beginning. So I'm actually going to split it up to the stuff I know about women and men. So I know that there was a total of 520 women, and I'm actually going to write that as N sub W. I'm going to give it a W subscript. I'm going to write my N for the men with a subscript of N. So it's N sub N, M. And that's going to be 506. The next thing we know is that the p hat, the sample proportion for the women was 14%. So p hat of W is 14%. The p hat for the men was 28%. So then the next thing you're going to do, you have to find your q hats for both. So now we have all of these values that we need. So unfortunately, we have a lot of steps to go on this. We're going to start by checking our conditions. And for our conditions, most of them are going to be the same as the previous ones that we did. There is one that when you're working with two samples that's super important though. So we'll do the ones that we know first. So first of all, they don't specifically tell us that we had random samples of men and women. We're just going to make the assumption there. In general, Gallup polls do have random samples, so we're going to just assume that they are random. Now, unfortunately for the success failure, it's going to be a lot longer. And there is really no way around that. So you have to do success failure for both women and men. So for women, you are going to do the NW P hat W, and you also are going to do the NW times the Q hat W. You do the same thing for men. That should be an M. So we have NM times the P hat M, and NM times the Q hat M. So when I worked them out, I ended up getting 72.8 and 447.2 and 141.68 and 364.32. I'd recommend you just do them on your own, just to make sure you can do it, but I think by now you're probably pretty good at these. By the way, just a fun little thing, just in case you didn't realize it, but you'll find out that whenever you do your success failure, that if you add up the values from the MP and the NQ for each of these samples, you'll get the sample size. Like if you add up 72.8 and 447.2, you end up getting your sample size of women. That's just a fun thing. It's not really that helpful, but it's nice to know. So now we come to our last condition. This is our new one. It's similar to what things that we've heard before, but it's a necessary one that you have to mention. So you have to also assume that your two samples are independent. And that usually does occur when you're doing randomization, but you do have to make that assumption. So now we're going to actually do our interval. So when you're constructing your interval, I'm going to do it as a 95% confidence interval. The first thing you're always going to do when you're working with two proportions is find their difference. So we're going to start by finding the difference. And it's always a good idea to do the higher proportion first when you subtract them. So the men have the higher proportion than the women, so I'm going to do that one first. The reason I'm going to do that is so that my answer will be positive. It's much nicer to deal with positive numbers. You can still do it with negatives, but it's less pleasant. So I recommend you do whatever your positive proportion is first. So our next part is our longer part, which is writing out our standard error, or standard deviation, but we call it standard error when we're working with P hats and Q hats. So the standard error, we had a big formula on the previous page that had the standard error in it, but I'll just rewrite it in the context of this problem with the men and women. So you're going to do your P hat of your men times your Q hat of your men over your sample size of men, plus the same thing with the women. And all you're really doing on this part is putting in all the numbers that you have in the beginning. That's why I think it's always a good idea to write it out in the beginning so that when you get to this, you just need to plug them in. So when you work this whole thing out, you will get the answer of 0.02509. Just to note, if you work this out on your own and you got a different answer and you still put the numbers in the same, I recommend you come talk to me about just calculator stuff. I always see a lot of students make mistakes putting this into their calculator. Seems like something that'd be really easy, but it's actually not. I tend to get a lot of people making mistakes on that. And you don't want to do the right formula, but make a mistake on something as little as calculator buttons. So we have our standard error. Now, actually, we only need to just plug the numbers into our confidence interval and we're done. So our interval is just going to be our difference in proportions, which we got was 0.14. And it's then going to be plus or minus. In this case, we have a confidence level of 95%, so we're going to use the z-star of 1.96. And we got our standard error just a second ago. It was 0.0251. And when you work this out, you'll find that you get 0.14 plus or minus 0.049, which I'm going to rewrite as an interval, and that gives me 0.091 to 0.189. So if you want, to be honest, 2 decimal places is a lot easier when you're working with confidence intervals, because then you can think of them in terms of percentages. So this is the conclusion that I would write. I think this is a good model conclusion. So it says we are 95% confident that the proportion of men who think men are smarter is between 9% and 19% more than the proportion of women who think men are smarter. So the way that we figure out the positioning of the words in here, so first of all, the 95% confident, that's already been said. So the first thing that we have here is the proportion of men who think men are smarter. And we put the proportion of women who think men are smarter. So the reason that we put the proportion of men first is because we use that first in our difference. You'll remember our difference of the p hats was p hat m minus p hat w. So we know that the proportion of the men was higher and the proportion of the women was smaller. So that's why we end up putting that first. You just have to show a comparison between the two. So we know that it's between 9% and 19% more than the proportion of women who think men are smarter. So go ahead and look at the questions that they asked at the end of this problem. The first thing they asked is there a gender gap about opinions, and what would we estimate the size of the gap to be? So we actually just answered the second question, which was estimating the size. You also need to mention one thing about whether or not there's a gender gap. So we are going to say there is strong evidence that there is a gap. And the reason that we know this is because 0 is not in our confidence interval. So you'll find as you do these types of problems, you will often find that you actually get negative numbers sometimes. If you get a negative to a positive, then 0 is in the interval. But in this case, we got only positives, and that means that 0 is not in the interval. So that means there is a definite difference. There is a definite gender gap.